Okay, I'm going to talk a bit. What probably will be the first of several conversations about polynomials and properties of polynomials. Let me begin by defining for you the general form of an nth order polynomial. So we talk about a polynomial is a function. It might be written as p sub n of x, like this. And the general form, we will find it be written as a sub n times x to the n, okay, plus a sub n minus 1, x to the n minus 1, raised to the power n minus 1, like this, plus a sub n minus 2 times x to the n minus 2 power. And then we keep on going all the way down, n minus 3, n minus 4, and so on, until we get a sub 1 times x, and then a constant, which I'll call a sub 0. Okay, so this is the general form of an nth degree polynomial. Notice the following properties we're going to impose. We're going to require that all of the coefficients, call them a sub k, all of these coefficients are going to have to be real rather than complex valued. So real valued. And I'm going to require that all of the powers, in other words, that n be an integer. So, for example, if n equals 2, we say that we have a second order polynomial. And n equal 3, we have a third order, and so on. So this is the general form of a polynomial. Now, most books, certainly at the high school level, are interested in properties, and so I understand why they're interested in some of the properties, and other properties I'm not sure exactly why they take such an interest in them. And one of the properties has to do with what they call the end behavior of the polynomial. So let's talk about that for a minute. Okay, end behavior. Then, in other words, what happens when as x approaches the value approaches infinity on the plus side, IOR behavior, or as x goes to negative infinity on the left side of the real axis. So in general, this end behavior, so as x goes to infinity, approaches infinity on the plus side, or x approaches negative infinity on the minus side. The end behavior is going to be completely determined by the largest power here of the polynomial. And the largest power is x to the n. If it's a second order polynomial, the largest power is x squared, and so on. So we look at the largest power. That if x squared, or x to the fourth, or any even power, then as x goes to infinity, we have, depending on whether a sub n is positive or negative. So if a sub n is positive, then as x goes to infinity, p sub x, or p sub n of x, the polynomial, also goes to infinity. So as x goes to infinity, p sub x goes to infinity. And as x goes to negative infinity, p sub x still goes to infinity. Because if x is even if x has a negative value, x squared is positive, and therefore a sub n of x squared will continue to go toward positive infinity. And that's dependent on a sub n being greater than 0. However, if a sub n is less than 0, then something different happens. Let me draw that right here in a little box here. If a sub n is less than 0, then as x goes to infinity, and as x goes to negative infinity, in both cases, p sub n of x will go to negative infinity. Okay. So p sub n goes to negative infinity. So let me do some graphs that illustrate that point for you. Pull up my graphing calculator. Okay. So here we are with the graphing calculator. And let's take y equal to x to the fourth. So we have x to the fourth plus, let's say x to the fourth minus x squared. Let's make it interesting. Minus x squared. Now, from what I've just said, the coefficient of x to the fourth is 1, so that's positive. So I'm saying y should go to plus infinity as x gets large, and it should also go to plus infinity as negative x approaches negative infinity. So let's plot this. So you see, you might be able to tell from this graph that this is exactly what is happening here, okay? You see that it goes, as x goes off in this direction, that the value of the polynomial still goes to plus infinity in both directions. Now, let me change the lead coefficient of x to the fourth to negative 2, let's say. Let me make it a little bit more interesting. Let me change this to 3 there. Now I do the plot, and in both cases I have that in this case I have that the value of the polynomial still shoots off to the negative infinity direction. So this is a simple example. Now, as I said, if x is an even power, as in x to the fourth being an even power, that's what happens. When x is an odd power, something a little bit different happens, and I will, let me show you what happens. Here, let me make the coefficient, again, equal to positive 1. Let me make this x to the fifth. Oh, okay, x to the fifth, 5. And then here's 3x to the fourth. But what's important is this power on the leading coefficient. So x to the fifth is odd. So what will happen in this case is as x goes in the positive direction, the function will go to plus infinity. But as x goes in the negative direction, the value of the polynomial, the value of the function, will go to negative infinity. Boom, look at that. That's exactly what's happening here. You can see we have, as x gets positive, the value of the polynomial goes to plus infinity. As x becomes negative, the value of the polynomial becomes negative infinity. Okay, same thing if I make this, I put a negative 2 here, a negative 2, let's make this plus 10, plus, let's make it a plus 100. How's that? Plus 100. Now let's see what happens. Boom. Well, you can't quite see it, but this is shooting up there, and then it turns around and it comes back down. Maybe I should make that a little bit smaller than 100. Let's leave it at 10. Boom, there we go. There it might be a little bit more clear what's happening. Okay, let me turn it, make it 5 here. 5. There you go. There you can see it happening. So it all depends on what the power is on the highest or power of x, whether it's even or odd, and it depends on the coefficient. If I change this to a positive coefficient, positive 2 instead of a negative 2, you'll notice that this will now go to plus infinity, and on this side it'll go to negative infinity, just like that. Okay, so let's see if we can't summarize our result. Okay, so if the leading power n is odd, then we have the following, that if the coefficient of that leading power is positive, then the polynomial will shoot off to plus infinity in the positive x direction, okay, and then it will shoot off to negative infinity in the negative x direction. So this is for positive, here let me write it like this. This is for a sub n greater than 0. If a sub n is less than 0, okay, the opposite happens. As x gets large, this thing shoots off to negative infinity down that direction, and then it shoots off to positive infinity in the negative x direction. So this is what happens when a sub n is less than 0. Okay, we've got a lot more about polynomials coming up.